Hi, I just wanted to remind us of something we've encountered in the past, which is this question. How many ways can we reorder the letters A, B, C? I made it into a password, but really we could just consider it a set of letters. So there is a first entry, and the counting principle says how many ways is there for the second letter, and then finally the third letter. Well, for the first letter that we'd put down, it could be any of A, B, or C. So there's three possibilities. We've used one of the letters to reorder. So now there's two remaining, and finally there's one. This is 3 factorial. This is also equal to 6. So this is just a little reminder of counting. Now I want to talk about permutations and combinations. And here the question is, in how many ways can we select 3 employees out of 4? And there are some distinctions in this question. So I've written down for you all the selections with order. So I've taken 3 out of the 4 letters, so A, B, C, and we could think of these as employees' name like Aaron, Bart, Charlie, David, whatever names you want to give them, it doesn't matter. So they're just designations for employees. So here in this first one, we have ABC, Aaron, Bart, Charlie, and it wasn't very specific how it meant to select it. So I could have also selected Bart, Aaron, Charlie, BAC, or I could have done CBA, or I could have done ACB, or CAD, or BCA. Now here would be your selections. Wrong pen. Here would be your selection without order. So it would just be ABC. It would be ACD. It would be ABD. And then finally it would be BCD. How did I get from this list to the bottom list? So the top list should notice, hey, there are 6 columns and 4 rows. There's 24. So what if I did 4 permute 3? Well, this would say I'm going to have 4 factorial, and then I'm going to have 4 minus 3 factorial, and that's just going to be 4 times 3 times 2 times 1 divided by 1, and that will be 24. So that is the selections without order. That's 24 of them. How did I get from this bottom one? Well, that's just 4, right? But this is also equal to, hey, I only counted one single row. So each row was different. So how do I know how many columns there are? That's just the reordering of the letters. Since it's 3 letters, there's 6 ways to permute them. So this is going to be 24 divided by 6, but another way of writing this is going to be 4 permute 3 divided by 3 factorial. So I could also write this as 4 factorial over 3 factorial times 4 minus 3 factorial, and this is n choose k, or better yet, since there are no n's and k's, is going to be 4 choose 3. In general, n choose k, which is also written as nck, is written as or computed as n factorial divided by k factorial times n minus k factorial. And this is a combination. And that's when order doesn't matter. So let me just give you a few examples, and you're going to choose permutation or combination. So here's going to be the first example. I need to select the top performers at my company, or the best workers. And the workers are A, B, and C. So how many ways can I award a top, first, second, and third performers from the group? Well, the answer is going to be a permutation. Order matters. A, B, and C is not the same as C, B, A. So here, being the first is different than being the last, right? If C is first versus C is last. Okay. Here's my second example. In how many ways can we form a committee of 3 people? Here, order does not matter because A, B, C is the same as C, B, A. You're on the committee and it's the same group of people, no matter in what order they're selected. Okay. So one of the key takeaways for today is this combination formula. Okay. It's very important to distinguish when to use the two formulas so that you can calculate your probabilities correctly. Thank you.